Welcome to Chapter 9, Straight Lines. This chapter combines algebra and geometry in what we call analytical geometry. The French mathematician René Descartes pioneered this approach in his 1637 book, La Géométrie. By representing geometric figures with equations, we can solve geometric problems algebraically. The straight line is the simplest yet most fundamental geometric figure. Coordinate geometry basics. The xy plane has two perpendicular axes, the x-axis running horizontally and the y-axis running vertically. Every point is located by its coordinates, x, y, where x is the horizontal distance from the origin and y is the vertical distance. We can calculate distances between points and find points that divide line segments. The distance formula gives the distance between 2 points P with coordinates x1, y1 and Q with coordinates x2, y2. The distance PQ equals the square root of x2 minus x1 squared plus y2 minus y1 squared. This comes directly from the Pythagorean theorem. For example, the distance between 6, -4, and 3, 0 is the square root of 9 plus 16, which equals 5 units. The section formula finds a point dividing a line segment in a given ratio. If a point divides the segment joining x1, y1 and x2, y2 in ratio mn, its coordinates are mx2 plus nx1 over m plus n for x, and similarly for y. The midpoint formula is simpler. When m equals n, the midpoint is x1 plus x2 over 2, y1 plus y2 over 2. The area of a triangle with vertices x1, y1, x2, y2, and x3, y3 equals 1/2 times the absolute value of x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. If the area equals 0, the 3 points are collinear. They all lie on the same straight line. The slope of a line measures its steepness and direction. If a line makes angle theta with the positive x-axis measured counterclockwise, then the slope m equals tan theta. The inclination theta ranges from 0 to 180 degrees. A horizontal line has slope 0. A vertical line has undefined slope because tan 90 degrees is undefined. We can find slope from 2 points on a line. If a line passes through P of x1, y1 and Q x2, y2, then slope m equals y2 minus y1 divided by x2 minus x1. Note that x1 must not equal x2, otherwise the line is vertical. For example, the slope through 3, -2 and -1, 4 equals 6 divided by -4, which is -3/2. Two non-vertical lines are parallel if and only if their slopes are equal. This makes sense. Parallel lines have the same steepness and direction, so they must have the same angle of inclination. If m1 equals m2, the lines are parallel. Conversely, parallel lines have equal slopes. Two lines are perpendicular if the product of their slopes equals -1. That is, m1 times m2 equals -1. This means the slopes are negative reciprocals of each other. m2 equals -1 over m1. For example, lines with slopes 2 and -1/2 are perpendicular. The angle between two lines with slopes m1 and m2 can be found using tan theta equals the absolute value of m2 minus m1 divided by 1 plus m1 times m2. This gives the acute angle between the lines. When m1 times m2 equals -1, the denominator is 0, confirming perpendicular lines form a 90-degree angle. Horizontal and vertical lines have special equations. A horizontal line has equation y equals a constant, like y equals 3. Its slope is 0. A vertical line has equation x equals a constant, like x equals 5. Its slope is undefined. These are the simplest line equations. The point-slope form gives the equation of a line through a given point with a given slope. If a line passes through x1, y1 with slope m, its equation is y minus y1 equals m times x minus x1. This is the most basic form of a line equation. For example, a line through 2, 3 with slope 4 has equation y minus 3 equals 4 times x minus 2. The two-point form gives the equation when we know 2 points on the line. If a line passes through x1, y1 and x2, y2, the equation is y minus y1 over y2 minus y1 equals x minus x1 over x2 minus x1. This comes directly from the slope formula and point-slope form. The slope-intercept form is y equals mx plus c, where m is the slope and c is the y-intercept. The y-intercept is where the line crosses the y-axis at point 0c. For example, y equals 2x plus 3 has slope 2 and crosses the y-axis at 0, 3. This form is very useful for graphing lines. The intercept form is x over a plus y over b equals 1, where a is the x-intercept and b is the y-intercept. The line crosses the x-axis at a0 and the y-axis at 0b. For example, x over 3 plus y over 4 equals 1 represents a line crossing the axes at 3, 0 and 0, 4. The general form of a line equation is ax plus b plus c equals 0, where a, b, and c are real numbers, and a and b are not both 0. Every line equation can be written in this form. For example, 2x plus 3y minus 6 equals 0 represents a line. This form is useful for finding distances. The distance from a point x1, y1 to a line ax plus b plus c equals 0 is given by the absolute value of ax1 plus by1 plus c divided by the square root of a squared plus b squared. This is the perpendicular distance. For example, the distance from 2, 3 to the line 3x plus 4y minus 5 equals 0 is mod 6 plus 12 minus 5 over 5, which equals 13 over 5 or 2.6 units. The distance between two parallel lines ax plus b plus c1 equals 0 and ax plus b plus c2 equals 0 is c1 minus c2 divided by the square root of a squared plus b squared. Parallel lines have the same coefficients a and b, just different constants. The distance is constant throughout their length. Watch out for common mistakes. Don't reverse the order in the slope formula. It's y2 minus y1 over x2 minus x1. Remember the absolute value in distance formulas. Always convert to general form before using the distance formula. Be careful with signs in the intercept form. Key formulas to memorize. Slope m equals y2 minus y1 over x2 minus x1. Point slope form, y minus y1 equals m times x minus x1. Slope intercept form, y equals mx plus c. General form, ax plus b plus c equals 0. Distance from point to line, ax1 plus by1 plus c over the square root of a squared plus b squared. Problem-solving strategy. First, identify what information is given, points, slope, intercepts, or angle. Choose the appropriate form of the line equation based on what's given. Convert between forms as needed. Always verify your answer by checking that given points satisfy your equation. Let's find the equation of a line through 2, 3, and 4, 7. First, calculate the slope. M equals 7 minus 3 over 4 minus 2 equals 4 over 2 equals 2. Using point slope form with point 2, 3, y minus 3 equals 2 times x minus 2. Simplifying, y equals 2x minus 1. Calculate the distance from point 2, 3 to the line 3x plus 4y minus 5 equals 0. Using the formula, distance equals going 3 times 2 plus 4 times 3 minus 5 divided by the square root of 9 plus 16. That's 6 plus 12 minus 5 over 5, which equals 13 over 5 or 2.6 units. This is the perpendicular distance. Straight lines have many real-life applications. GPS navigation systems use coordinate geometry to find routes. Computer graphics and video games rely heavily on line equations. Architects and engineers use these concepts in construction. In physics, the trajectory of objects under constant velocity follows a straight line path. In this chapter, we learned that slope defines a line's steepness and direction. We studied multiple forms of line equations: point slope, two-point, slope intercept, intercept, and general forms. Parallel lines have equal slopes, while perpendicular lines have slopes whose product is -1. We derived formulas for distance from a point to a line and between parallel lines. Thank you for joining Chapter 9 on straight lines.